started thinking of the log of a number as just another number and treating it as an integer.
The one log squared, Spencer got that right. Nobody else in the class got that one right.
What? Oh, the ln 7x squared dx?
Yeah.
Yeah.
First test you had something like that.
Thanks for reminding me.
I didn't know where you were going with that.
Yeah, that's
You guys should have.
Got it? Y'all don't have it.
I'm about to work it. You guys ought to be ashamed of yourself. I didn't, if you missed it all together, I counted off -4 instead of -8 because so many people had missed it. But you talked yourself into missing it's all I can tell you.
Yeah, I forgot you could full it out like that.
Oh, you don't even have to do that. And that is, I remember, let's see, it was this one on one test.
You're not on.
Wasn't that the way it was on one test?
You're not on.
There, that's happened to me a lot in my life, not been. My light's been dim.
Yeah, my mind was blank on
Yeah, Spencer.
the way
Maybe you would have missed it.
Could have argued something about it.
Let me show you how I would have worked it. What I would have said is that this is equal to the integral of log 7 plus log x squared dx. That's what I would have done. And I would have used fall on it, back to my mother, and I would have said then that's equal to the integral of I'll just write it the way you would have written it. I left the seven off here, didn't I? Now that's the way I was going to do it, would have started it. And then I1, I2, and I3. I now have that's one way. The other way is to just do it directly. And that is, I let u be equal to ln x, log 7x squared. And there is no 7 there. That was right not to put it in. Because that was the whole purpose of doing it the other way, was to get it out of there. And dv equal dx. Why don't you remember that you can't integrate log x? You can't integrate log x. So don't try it. And remember that you can take the derivative of it. You can take the derivative of it. So do integration by parts every time you have one. And what?
Oh, I was just saying, I sat there on my scratch paper and took forever trying to find a way to integrate log of X.
Well, and I understand, except that I worked one like that. And I told you that at the time.
They have to split it.
Okay, so then what you do is you start taking derivatives. Well, I'm going to have to do it twice, so I'm going to do a table. And I'm going to make that plus, and I'm going to take the derivative, and I get 2 log 7x times 7. Then I get x. I'm making the table, right? Where'd the 7 come from?
The derivative.
The root of 7.
Chain rule, right? Chain rule. Now I need to do it again, so I get 14 times 7x over 7. And then here I get minus plus x squared over 2. In the way you take the derivative of the log, you put what's inside the log on the bottom, you take the derivative of it and put it on the top. But looking at this last line, that doesn't have anything but x's in it. And that's a piece of cake, right? So what I'm going to do next is, I'm going to say I1 is equal to the integral of 14 times 1 over x times x squared over 2 dx, which is equal to 7 times the integral of x dx. Now, anybody feeling silly about not being able to work that problem? Which is equal to 7 halves x squared. I know, plus c. So now back to the original problem. I is equal to x log 7x squared minus 2x log 7x plus 7 halves x squared. I think you guys made a mountain out of a molehill.
Yeah.
I think you saw that square on that log X and just went nuts.
I kept thinking about the first test. I thought you might want to check some of the, I guess that's kind of what you did.
Questions? Okay. We've now done 8.1, 8.2, 8.3, and 8.4 now. 8.4 is always my favorite. Suppose I had this integral. as you well know, there's nothing in the table, even if I let you have the table on that, there's nothing in the table with that.
Partial
How are you gonna integrate that?
Partial
Denominator
fraction.
to U,
Say it again.
denominator to U, and then you could multiply.
Okay, that's exactly the way to do it, if you can. Here's the problem. du is going to be 2x minus 2, huh? 2x minus 2. Then you're going to have to try to somehow change 2x minus 2 to 5x minus 3. And that's not so easy.
Did you foil the denominator and
That's what I was
split it into two fractions?
Yes.
That's what I was thinking.
Yes, Byers?
Partial fraction.
That's exactly it. Both of you are telling me the same thing. Now, do it my way. Do it my way. I've got two students that have to recopy problems for me to I offered the opportunity to recopy problems because I counted off -8. I'm just not going to put up with it. I'm not going to have chicken scratch all over a test. So do it my way. Off to the side, I want you to rewrite this as and I want you to tell me that that's equal to you just got to be able to factor that. If you absolutely cannot factor it, I'll show you how to use the quadratic equation to get around it and know how to factor it. If you just can't factor it all, I'll show you. But you just got to be able to factor that. Okay? Now, here's what we're going to do. If I wanted to make this be if I wanted to rewrite that fraction as two fractions, in order to put it back together, what would I have to do?
Use a common denominator.
I would have to find the common denominator. Does everybody agree? So I don't know what to put up here, so I'm going to call it big A. And I don't know what to put up here, I'm going to call it big B. Now I'm going to put it back together. And I'm going to have A times x plus 1 plus b times x minus 3. If you write it like that, you're wrong. And I'm not going to let you get away with it. This, see what you're telling me is that this is equal to this, is equal to this, is equal to that. Do you really believe that? Do you really believe that? Why? Because there's no denominator here, right?
Yeah.
Okay, so what I want you to tell me is this. All you have to do is I want you to tell me that if I start over right here and write something on both sides of the equal sign, am I saying that this is equal to this? No, I'm not. Do you follow what I'm saying? A one-sided equal sign tells me I can go all the way up. But if you start over, you're starting a new sentence, aren't you? I had a graduate school professor that was so bad. You think I'm bad. He had us put a period right there because it was the end of a sentence. It is, isn't it? Is it not? Okay? So here's what I said. I said, now I'm going to put these back together. Now I'm going to put these back together by finding a common denominator. Isn't that the way I find a common denominator? Yes or no?
Yes.
And then I'm going to forget about the denominator for right now. I'm just going to say that if all of these are equal, the numerator on the right is equal to the numerator on the left. Doesn't it have to be? Doesn't it have to be? Okay. There are two ways to do this. The easy way and the hard way. Could I suggest to you that I'd highly recommend the easy way? Okay? I need to know what A and B are, don't I? Everybody agree?
Right.
So here's what I'm going to do. I know that that's true. I'm going to say that if x is equal to 3, then I have I hope everybody would agree that there's no smoke and mirrors, right? Does everybody agree? I just put x into the equation, and can't I put anything I want to in there as long as I put it in both sides? Everybody agree with that? Now, I'll bet you noticed, didn't you? So now I have 15 minus 3, 12 is equal to 4a. And what happened to the b?
Okay. It's gone.
It disappeared because it got multiplied by 0, right? So doesn't that tell you that a is equal to 3? Now I'm going to say if x is equal to minus 1, I have 5 times minus 1 minus 3 is equal to a times 1 minus 1 plus b times minus 1 minus 3. Does that look right?
The first one should be negative.
It is negative.
No, yeah, you just switched the sign. Okay. Switched it around, Mom.
What did I do, Jake? I didn't mean to do anything tricky.
No, it's just instead of the negative one being where x is.
Yeah.
It's.
Oh, I didn't mean to do it.
No, I see it now.
Yeah, but I shouldn't have done that. I wasn't. The whole reason I wrote that line, sometimes I don't even write that line, but the whole reason I wrote that line is so y'all would know where it came from. Sorry. This is minus 8. Is that slick or what? All that is the book's going to tell you to multiply those numerators out and set each power equal and solve a series of equations.
Yeah, that's how I learned how to do it.
What?
That's how I learned how to do it.
Say it louder.
I said that's how I learned how to do it.
Is that how you learned how to do it, or the other way?
The other way.
The other way. You like this way better?
Yeah.
All I'm telling you is, why did I pick those two?
To zero out the other side.
That's right. I picked those two so I could zero out all but one of the letters. And once I zeroed it out, then I solved for that one, and it got real easy, huh? So do you see how to pick the X's? I'm going to work one the other way, and I'll show you the other way, because every now and then I have to do one that way, but I try everything easy first. Okay? Now would it be correct to say that I is equal to the integral of 3 over x minus 3 Would that be correct to say? Didn't I take what was inside the interval and recopy it? Didn't I do that? And that equal means those two are equal, this equal means this is equal to this is equal to this. Now I know what A and B is, so didn't I just put 3 in the place of A? 2 in the place of B? Is everybody okay with that?
Yeah.
I need to know, I need to see some affirmation here. Everybody okay with that? Okay? Now I have shame on me. What's that equal to?
Natural
Ln.
log.
Thank you, Jay. That's all. I just wanted to hear that word. That's right. Spencer is telling you what I was going to tell you. Say it again, Spencer. Let me point for you. Spencer says,
We make the denominator u. And
that's u.
Would be 1 over u, which the integral is the log of the absolute value.
Is that cool or what? Now you know why I like partial fractions. That's just cool. I'm telling you, right off, I can't think of a real nice way to integrate that. I may not can think of an ugly way to integrate it. I just hadn't tried with anything other than partial fractions.
I could find that integrated.
I think,
Give me a couple of hours.
That'd be easy. Just you find a common denominator.
yeah, I should say, I can't think of any correct way to integrate that. I saw some funny integration this semester, so I know some of you can do it. Did I tell you I had a professor in graduate school that gave us, and this was a really hard class, and he would give us proofs, and it said prove or disprove. And I told him, I said, you ought to at least tell us which one to do, because I can do it either way. And he thought about it for a minute and just laughed. What I was saying is, I can use faulty algebra and prove anything I want to. Everybody follow what we did? It's called partial fractions, and we break it up into fractions, then integrate each fraction. And it'll almost always be logs. Every now and then it gets to be an inverse trig function, but it's almost always logs. Questions? All right. Let's do another one. This is example 1 on page 473.
I was hoping we did. I thought each one was closed, so I thought it was late. My mom said it was closed.
Coming back, it's better.
Heard a bunch of racks.
Huh?
Heard a bunch of racks.
There's one over here.
So tell me what we're going to do. Three fractions, huh?
Yeah.
3 fractions? So, I'm going to have then off to the side, if you don't want to rewrite the whole thing, that's okay with me. But I always rewrite it, because I'm, particularly on a test, I'm trying to keep from making a silly mistake. No need for any permits.
Yeah.
No pencil, perhaps, from either one.
Is that the way you would have done it?
Yeah. Appreciate it.
Everybody agree? Everybody agree?
Yeah.
So now, don't I know then that x squared plus 4x plus 1 is equal to a times. I'll write it and you tell me if you think it's so. How do you find the common denominator for 3 fractions like the one up here in the upper right corner? Don't you multiply by the product of all the denominators? So take for example right here. Wouldn't I multiply this little fraction right here by x minus 1 times x plus 1 times x plus 3? Would I? Would I? And Jake, what happens to the x minus 1s?
They cancel out.
this problem. Whenever, whenever you have to let X stand for something, I mean, what are you gonna let X stand for?
I thought you'd never ask. I was waiting on you to ask. Is everybody okay with that step? Now watch what happens. If I want A to go away, I don't have to make but one of these 0, do I?
Oh, because 0 times.
Is that right? I don't care what the other one is as long as one of them's 0. Everybody agree? So, I think what I'm going to do is I think I'm going to start by let X be equal to -1. So I have -1 squared plus 4 times -1. It plus 1 is equal to A times 0 times 2 plus B times -2 times 2 plus C times -2 times 0. What do you think? Y'all know to watch me, don't you? Be careful. See if I'm right.
It's right here. Only one where it matters is in the middle.
Exactly right, Daniel. That was my idea. So don't I know, so help me, if on that test you write, don't copy what I'm about to do, so help me, if you write this on that test, and you tell me that that is -1 -4 plus 1, Ms. Voss is going to have to teach you the rest of the semester because I'm going to have the big one. And I'm telling you, now that I've said it, I'm hoping you won't do it, but I have had it happen in Cal too. So this is equal to 1 -4 plus 1, and does that look like a -2 to you? And then here, don't I have -4b? So 1/2 is equal to b. Okay. Now, I'm going to let X be equal to -3. Where did I get the -3? Well, you know where I got it. But you're supposed to notice in advance that A has a 0, B will have a 0, but C won't. Isn't that just exactly what you want? So now I have -3 squared plus 4 times -3 plus 1 is equal to 4 times -2 times 0 plus B times, not 4, A, B times -4 times 0 plus C times these two are gone. So I have 9 minus 12, that's minus 3, plus 1 is minus 2, is equal to 8C. Or C is equal to minus 1/4. Does that look right? Okay. Now, let x be equal to, I've done minus 1, I've done minus 3, looks like I need to do 1, don't I? So I have then 1 squared plus 4 times 1 plus 1 is equal to A times 2 times 4 plus B times 0 times 4 plus C times 0 times 2. And this is looking a lot like 6 to me over on the left-hand side. And I get 8A is equal to 6, do you? And therefore, 6/8 equals A, or A is equal to 3/4. Remember my father's marvelous saying, it's all over but the shouting? So I've got then A over x minus 1. So now I say, watch me do it this way. Now I say, without having to copy that whole thing, that's why I called it I, right? I is equal to A over x minus 1, but A is equal to 3/4, right? So this is 3/4 times 1 over x minus 1 dx. Now B is equal to 1/2 over x plus 1. One half times 1 over x plus 1 dx. Now, plus, I think it's minus. It is minus 1/4. I'm going to leave that plus there because we're still new at this game and I'm going to take it a step at a time. Minus 1/4 times 1 over x plus 3 dx. Do you agree with what I did? It's a little awkward that one's on one page and one's on the other. But remember what I did. I went to some great lengths to say that what's inside the integral. And I think I really do want you to copy that. Just copy that and then write it like this. Because isn't it this step that gives you the right to break it up into 3 integrals? So then all I do is after I found them, I go back and I say I is equal to the integral of this plus the integral of this plus the integral of this. And the reason I can do that is because I showed that those two were the same. Do you follow what I'm doing? They're not all going to be this easy. You better get it now. Everybody follow what I'm doing? Okay. So now, don't I have 3/4? I could have pulled the 3/4 out in front to begin with, right? Times the log of x minus 1 plus 1/2 times I don't need the parentheses, times the log of x plus 1 plus, nope, minus 1/4 times the log of x plus 3 plus c. I've told you before, I'm somewhat sloppy with these parentheses and absolute values, but if you do it, whatever you do, be consistent with it, and I won't ever count off for it. Questions? Question? Pretty slick, isn't it? Don't you ever now and then just have to say, that's pretty slick? And plus, isn't it a whole lot better than those trigonometric integrals and the trig substitutions?
Yeah.
Okay?
That wasn't too bad.
Yeah. Example 2 on page 473. Any ideas? You know, I think I could work that one. I think I could let u be equal to x plus 2. Then I think x would be equal to u minus 2. And I think I could get out of that using a natural log and an inverse tangent. That's what I think. And not use partial fractions. But I also think partial fractions is a lot easier. Same way, right? I sometimes write stuff up there that I don't mean because I'm thinking about something else. But this one time, I really mean it. I really mean that square. I really mean that square.
Why?
Well, I mean, when we start trying to figure out A and B, if you didn't have it, we wouldn't be able to zero anything out anyway.
Yeah, that's correct. You gotta have it to make this thing work. That's one answer. How about this? Here's rule 1. Did I get it right, Ed?
I was looking that stuff over last night.
So, do you follow what I'm saying? If this had been x to the third, if that had been a 3, wouldn't I have had x plus 2 to the third, x plus 2 squared, and then x plus 2? So you have the highest power and all other lower powers. Okay? But once I say that, then everything else works the same.
So like if it was x plus 2 cubed, you'd have x plus 2 cubed plus x plus 2 squared plus x plus 2.
That's exactly what I'm saying. Okay?
Now, it'd be a C or a 1? You'd have to find an extra one if we.
Yeah, it'd be a C. Always letters in the top.
Okay.
Until rule 2.
Oh, great.
So,
Thanks for that foreshadowing, isn't it?
6x plus 7 is equal to a times x plus 2 plus b times, nope,
Cancel out.
yes or no?
Yeah.
What's the common denominator on the right side? On the right side, up there at the top, what's the common denominator?
X
The
plus
least common denominator.
2, x plus 2 squared.
Louder.
X plus 2 squared.
X plus 2 squared, is it not? Is it not?
Yeah.
So, if I multiply this fraction by x plus 2 squared, go ahead, Jake, tell them what happens to the x plus 2 squared.
Cancel out.
I'm beginning to feel a twinge. But over here, don't I have x plus 2 squared over x plus 2? And doesn't one of them divide out and you're left with the other one?
I like
And
this.
the other one's on top.
Yeah.
It's going the right way.
In fact, I think this time, I'll write it out.
Just once you make the denominator the same, you just take it off, and what you're left with is
Exactly.
plus b,
Now, multiply
whatever you divide at the bottom.
1 above, and I'm going to call that equation 1, okay? It's because I'm too lazy to write it. X plus 2 squared, huh? That means every single term on both sides, doesn't it? Isn't that what, when you multiply an equation by something, doesn't that mean every single term on both sides? So now I have 6x, I better move over, because I have 6x plus 7 times x plus 2 squared over x plus 2 squared is equal to a times x plus 2 squared over x plus 2 squared plus b times x plus 2 squared over x plus 2. Everybody agree? I can do that, can't I? Didn't you learn in Algebra 1 you can multiply an equation by anything you want to as long as?
Both sides.
The golden rule.
Hmm?
The golden rule.
Yeah. Okay. All right, Jake. What was the action right there?
It disappeared.
Hmm?
It disappeared.
And there. But here, don't I still have an x plus 2 left over? So now do you see where I got everybody? Any questions about that far?
Kind of a complicated way to look at it, though.
Well, it is the 100% right way to look at it. What I usually do is I just multiply the right-hand side by the least common denominator, which is always that.
Well, I mean, if that were just any other fraction with integers, you'd only have to multiply one side, which is the right side, by x plus 2 to get to make it equal to the rest. So
There you go. That's another
all
way
you
to
have
do it.
write.
Well, I guess that's what we did, though, wasn't it?
Yeah, I mean, it's just. kind of-
What's next? Somebody tell me the next step.
Plug in.
So next you're doing -2.
Very good. Let x be equal to -2. So now I have, that's a -12 plus 7 is a -5 is equal to a plus b times 0. Is that right? Now, I still need to find b. Any suggestions? Any suggestion?
X equal to 1 or 0.
Yeah, x equals 0 would probably work. I think I'm going to do it this way. I'm going to call this equation 2, just so I have a name for it. So now I'm going to substitute a equal -5 and x equal 0 and 2. You don't have to do it this way. But wouldn't that give me 7 is equal to -5 plus 2b? Is that right? Isn't it easy enough to find b now? So don't I have 12 is equal to 2b and b is equal to 6?
Miles, do a little bit of extra if you had to do, you could just look at it and say that.
Yeah,
Yes.
what the other way to do it, and the way Ms. Voss would tell her, this is Math 98. What Ms. Voss would tell her Math 98 class is put -5 in the place of A, and then solve for B, right? But this way, that's pretty easy way to do it, and I've done it for years that way, and it seems to go fast. letting x be equal to 0 has the effect of making the x's go away, doesn't it? And then you can get a number for b. That's why I do it. Questions? Now, wouldn't you say then, based on all of this, minus 5 and 6, wouldn't you say that I is equal to the integral of minus I don't want to skip too many steps, is equal to minus 5 over x plus 2 squared dx plus the integral of 6 over x plus 2 dx. Is that right? Everybody agree? Now, this is I1, and this is I2. That's good enough for me to just tell me what they are. And then I'm going to do I2 first because it's the easy one. I2. Oh, I need to say that. I'm not ready to clean it up, to call it yet. I'm going to say that I is equal to minus 5 times 1 over x plus 2 squared dx plus 6 times 1 over x plus 2 dx. And this is equal to I1, and this is equal to I2, and I is equal to minus 5I1 plus 6I2. That does two things for you. The first thing is it makes the integration a lot easier, doesn't it? Because you don't have to fool with constants. The second thing is by writing it out like that, and I want to see that from here on, I'm tightening the noose a little bit more. I want to see you write out what I is in terms of I1 and I2. Then it will cut down on your mistakes when you go substitute it back in. Does that make sense to you? Okay? So now all I do is anywhere I want to on the paper, I don't care, anywhere on the paper, I want to see I1 equals, and then I want to see equals going down a page and the answer. But in this case, I'm going to do I2, and I'm going to say that I2 is equal to the log of x plus 2. Huh?
6. 6 times the log of the
Yeah,
next case.
well.
No.
Not just I2.
I left the 6.
6 up there.
I left the 6 right there.
Okay. Yeah, you can go there. And then you have to
And let me show you what else you need to put right here. How about if you go ahead and put the plus C right there? Won't that help you remember it also? Okay? Now, I1. I1 is equal to the integral of 1 over x plus 2 squared dx.
It's 1 over x plus 2.
U is equal to x plus 2. Du is equal to 1. is equal to dx, right? So then this integral is equal to 1 over u squared du. Is that right? Which is u to the minus 2. Which is, add 1 to the exponent, you get u to the minus 1, don't you? And that, isn't that 1 over u? Divided by the new exponent, which is dividing by minus 1. Which is equal to minus 1 over x plus 2 squared. And I don't have to put the plus c because I know I'm going to take care of it when I get to I, right? If you want to put it, by all means do. Okay?
Do you need the
Where'd your
squares?
square come back into play?
Oh, I don't know. Okay? Everybody? So now I say I is equal to minus 5 times, is equal to minus 5 times a minus 1 over x plus 2 plus 6 times log of x plus 2. Or I is equal to 5 plus c, 5 over x plus 2 plus 6 log x plus 2 plus c. And there it is. Questions? Everybody okay with it?
Yeah, I have to look over the left side because I forgot you'd already taken the integral when you wrote negative 1 over u. First instinct was to write the log of, but it's already been done.
I used to do that, didn't
And plugging u back in,
I? Yeah.
end up writing the log of x plus 2.
Questions? Anybody? So the only thing that made this one different is I had a power in the denominator, right? But now you know what to do with that. Okay? It does get a little harder though.
Something easy.
This is example 3, which leads me to rule 2. Ed, you came in at exactly the right time.
I think we should remind everybody, you need to know how to factor at the Bass 99 level.
Yeah.
If you don't, disasters can happen.